Here we come to the last of our lessons about specific u substitutions using trig functions, and this one has to do with even powers of secant. Your strategy here is, if you have an even power of secant, reserve a secant squared next to the dx. Convert the rest of the secant terms into tangent, using secant squared equals tangent squared plus 1, and then finally use u equals tangent x for your substitution. You're going to find that these problems run in a very similar way to the way that the odd powers of sine and cosine and the odd powers of tangent worked. So follow the strategy and you'll be fine. We've got a couple examples, so we'll try those out. So here's the first one. Notice that this problem has an even power of secant. And so the way that we're supposed to do this is we're supposed to reserve that even power of secant. So we sort of pull our secant squared x dx over here. Then we have our square root of tangent x over here. And the idea is any secants that were left over here we're supposed to convert into tangent. But as you'll notice, I've got my secant squared x over here. Everything over here is already tangent. Remember that the derivative of tangent is secant squared. So we're already perfectly set up. If I use my u as tangent x, my du will be secant squared x dx, and I'm like ready to walk out of the problem, right? Keep in mind I do still have bounds here, 0 to pi over 4. So I now have the integral of the square root of u du, and we have not yet reviewed changing of bounds, so it's worth mentioning here. How do we change these bounds? And very specifically, do not write the old bounds here. If you're going to do anything, just don't write any bounds, but never ever ever just write the old bounds here after you've done a u substitution. Right? The way that we do this is these, I used to sort of say these are x bounds. This is really x equals 0, x equals pi over 4. Down here, we need to know what the corresponding u values are. So all you have to do is take these values that you have and plug them into your u substitution. You know, if I do u equals the tangent of pi over 4, I'll find that that's 1. So great, my new upper bound is 1. When I do u equals the tangent of 0 is the sine of 0 over the cosine of 0, that's 0. Great, so my new bounds go from 0 to 1. So now I do this integral. This integral will be 2/3 u to the 3/2, evaluated from 0 to 1. That gives me 2/3 times 1 minus 2/3 times 0. And so the numerical answer for this problem, 2/3. Okay. So this was sort of both a review of how we use this even powers of secant method and also how we change bounds when you do a u substitution. Okay. So here's a problem that has a little bit more going on with it. It is one of those differential equation problems, but you've seen a few of these now. You should know that this is just really just going to do an antiderivative. Notice that there is an even power of secant here. And so we're going to use that method. I'd really like you guys to pause the video and at least try the first few steps of this. Try and get yourself at least to the u substitution, then maybe check back in with the video to make sure you're doing okay with it. So let's try that. So, not surprisingly, we have our dy, we have our secant squared x, secant to the 4th x over tangent x dx. We're integrating both sides, so we have y equals, now when we have an even power of secant, we reserve secant squared x dx. When I do that, it means that I have secant squared x remaining, and then we're supposed to convert those secants into tangents. So y equals the integral of tangent squared x plus 1 over tangent x times the secant squared x dx that we reserved. And once again, we're in this position where this is ready to be the du because everything over here is still tangent. So if I make my u tangent x, my du will be secant squared x dx. I'm substituting all of that in. I end up with the integral of u squared plus 1 over u du. So this effectively should have been your u substitution. Hopefully you were able to get through all of that. If you did, you're getting the hang of this. If you haven't already done so, try and finish this integral out on your own. It should be pretty straightforward. It'll be the integral of u plus 1 over u du. I got that just by splitting this into two different sections. So then I have 1/2 u squared plus the natural log of the absolute value of u plus c. And then we remembered that our u was actually tangent, so y equals 1/2 tangent squared x plus the natural log of the absolute value of tangent x plus c. And there's our general solution. So one more example for you, secant to the fourth of 3x dx. We're taking the antiderivative. Hopefully this is one that you can do on your own. So pause the video, at least get through the u substitution, and then check back in before you finish the problem on your own. So just like we've done with many of these, we reserve a secant squared 3x dx. And I'm even going to try and skip a step here. I know that right here there's going to be a secant squared x, and it's going to be my job to change that, to convert it. So I'm just right now going to convert that into tangent squared 3x plus 1. Because effectively that's what this integral is going to turn into. There's going to be two secant squareds, one's going to turn into tangent, the other we're going to leave alone. Now that we've done this, we're ready for our substitution. U equals, and we do need to pay attention here. My substitution is u equals the tangent of 3x. That means that my du is 3 secant squared 3x dx because of the chain rule, right? So in this case, I'm actually going to get 1/3 du. So the secant squared 3x dx is 1/3 du. So when I plug things back in, I'm going to end up with the integral of u squared plus 1 times 1/3 du, so I'll pull the 1/3 out front, and I'll leave the du on the end. Okay? And surprisingly enough, this actually ends up being this is just a really straightforward integral. So we've got our 1/3, there's going to be 1/3 u cubed plus u plus c, and then the last thing I have to do is put my tangent back in. So this will be 1/9 tangent cubed 3x, not a very good 3 up there, tangent cubed 3x, plus the tangent, plus 1/3 the tangent of 3x plus c. Okay, so hopefully these made sense in terms of how we work with these when we have an even power of secant. If you've got questions, make sure you write them down, or make sure you really know what they are, because you'll probably forget before you get to class tomorrow. I'll see you then.